All right. Thanks for joining us, everyone. Today, we are very lucky to be hosting Wanseob Lim, all the way from Korea, and he will be introducing to us Zkopru. A quick introduction, Wanseob is the author of Zkopru and project coordinator for the PSE group in the Ethereum Foundation. So that's short for Privacy and Scaling Explorations. So without further ado, Wanseob, pass the floor to you.
Thank you for inviting me here a lot, and I'm really happy to be here. And today I'm gonna share what is Zkopru in more kind of a more educational purpose, I guess, like just for introductory stuff for about how the privacy works here and what should we concern or think about when we build a layer 2 stuff. So yeah, let me start my talk about Zkopru. The reason why I started the Zkopru project was like, I remember there was like 2018 or 2019. Actually, I don't remember the exact date, but once I traveled with my friends and went to a restaurant and split the bill using mainnet at the time. And my friends just registered my address to the Etherscan watch list, and they were watching that my account is getting liquidated on the MakerDAO. So actually it was a pretty frustrating experience that, oh, there's really no financial privacy at all. So that was a reason why I started the privacy protocol. So around 2019, Barry founded a PSE team at the time, and I joined the team, and we started to build a protocol from that time. Yeah, so basically, private transaction protocol mostly depends on UTXO model. Actually, I have never found any other solution to preserve the privacy of transaction without the UTXO model. So that is because it is pretty difficult to hide information with a general state machine. So let's see how it works briefly. So the first mission is like, for example, transferring 5,000 USD from Alice to Bob. In this case, let's assume that Alice has 2 coins now. This is a UTXO model. So 2 coins now. The first one is 3,000 USD, and the second coin is 4,000 USD. And then Alice uses these 2 coins and creates new coins for Bob. This is a basic UTXO model, right? So just nullifying the spent coins here. So you can see that the total amount of the USD should be same before and after here. So Alice spends these 2 coins and creates a 5,000 USD coin for Bob, and the remainings for her here. Okay, and then let's think about in a more graphical way. So we can think like there are 2 unspent coins, and we make a transaction that spends these 2 coins, and we generate new unspent coins here, and then mark coin A and coin B are spent. So we can have these 2 kind of pools. So the first one is like unspent, and the second pool is spent. And actually, without removing the coins from the unspent coin pool, instead of that, we add spent coins into the spent coin pool. Then in this scenario, how do we preserve the privacy here? Like, so to preserve the privacy here, we have to hide the value, and also we have to hide the transaction graph. I mean, the hiding the transaction graph means like we want to hide this transaction. We want to hide the information about which coins this transaction is using to generate new coins. That means hiding the transaction graph. And also hiding the volume is like, oh, this transaction spent some coins and generate new coins, but I won't let you know the exact detail of the amount and the address. So we should satisfy these two conditions here. So the first, to hide the transaction graph, actually, it should be work like the Tor network. I mean, not Tor, I mean the Tor network. So I'm sorry, Thor is my colleague in the team. Yeah, by the way. Yeah, so it should work like a Tor network, like a spent coin X. There is a spent coin X, but we don't know which coins we have spent to mark this X. Yeah. So then how can we do that? Is about the combination of the Merkle tree and the ZK-snark. Actually, this is a commonly used scheme, which is called membership proof using ZK-snark. And just for your information, there is another way that we can do this private membership proof with a better efficiency, which is called CAULK, C-A-U-L-K, which is based on the vector commitment. But in our case, actually, this is designed like 3 or 4 years ago. So it is based on the Merkle tree model now. So, but the basic is pretty similar. So I'm gonna explain with the Merkle tree model. I think that maybe some of our members, I mean, if Column Pro members are familiar with ZK-snark, but some of them are not familiar with what is ZK-snark and how it works. So this is a simple diagram about how ZK-snark works. ZK-snark is a protocol to guarantee some logics. So for example, this is a program. So we have some public input, public information. Just a moment, please. I need some laser point here. Does it work? Okay, great. Yep. Yeah, so we have some public inputs here. So you can, oh my god. So this is a program. So we have some public inputs and private inputs. And what we want to do is like these public inputs and private inputs satisfy some conditions, some logics. For example, public inputs can be like 3 and 2, and private inputs is like 6. And we are just guaranteed that 3 times 2 equals 6. That the logic is like just multiplication here. So ZK-snark is just a protocol that guarantees public inputs and private inputs satisfy these logics. Then its result is like there is some public outputs and also the proof that all the inputs and circuit satisfying the every conditions, and we can guarantee that in a cryptographical way. So the verifier can just verify using these public inputs and public outputs and circuit information and the snark proof. Then, okay, this proof is true or false. Then let's see how it works in the Merkle tree membership proof. Okay, yep. Okay, so you are all maybe familiar with how the Merkle tree Merkle proof works, right? So this is a root, and we can just construct. If you want to prove that this green leaf is one of this group, then we just make a Merkle proof, like using this sibling 1, sibling 2, and sibling 3, and the hash of the leaf and the sibling 1 and hash of the sibling 2 and this one, hash of the sibling 3 and this one should be the root. And we're gonna verify this through the ZK-snark. So here, I just marked the private inputs as green items here. So which means like here is a leaf, and here's a leaf, but you don't want let others know the information about this leaf. And also, if you let others know the sibling information, it is also revealing the information of the index of this leaf. So we also want to hide these sibling items too. So these 4 nodes should be the private inputs here, and the public inputs here is the root value. So we are just compressing the group data into one Merkle tree root, and we're gonna say like, oh, this one is one of this group. This leaf is just one of this group. And the circuit logic is simply the Merkle proof. So node 1, this is the node 1 is the hash of the sibling 1 and leaf 1, and node 2 and node 3, and root value should be the calculated node 3 here. So so you can see like in this diagram, we have a logic for Merkle proof and we have public inputs, the root value, and private inputs, the leaf and the sibling values, and then we can have a snark proof that this one is one of these group, and the verifier can verify this using a ZK-snark that okay, this proof is true. So this is how ZK-snark and membership proof works. Okay. Is there any question?
I think we'll just keep the questions to the end, probably.
Okay. Okay, then. Yeah. And the next is about then how do we make the UTXO pool for the privacy for the anonymity pool. So what we did is like making it as a pan only Merkle tree. This is a little bit tricky. I mean, a pan only Merkle tree is kind of a very big sparse Merkle tree. So we are assuming that the other leaves starts from 0, and we are just following the items from the first index, like from index 0, 1, 2, 3, or 4. This is because if we just construct a Merkle tree, the standard Merkle tree, we cannot use a kind of some fixed constant data, which can reduce a little bit of hash computations later. So we use a append-only Merkle tree for the membership proof. Yeah, actually, this was too much information, I guess. And yeah, and then let's see about what should the protocol look like. So UTXO pool should be a append-only Merkle tree, and the nullifier pool should be a mapping or sparse Merkle tree. I mean, we construct a Merkle tree for the unspent coins, and also we need a space that we gonna mark some spent coins, and we can implement that using mappings. If we implement this as a layer 2 solution, then we can just write smart contract code to describe the protocol. So we can use mapping, or we can also use a sparse Merkle tree. Like this one is already used. So sparse Merkle tree is a Merkle tree that every leaf is 0, starts 0. So, and has a fixed depth, fixed size. So for example, we have a sparse Merkle tree which depth is 5. Then we have 32 items, and every item is 0, and we can update the item like let's assume that we updated the item of index 10. Then we can just prove that the 10th leaf is not 0, which means it is already used. So sparse Merkle tree is usually being used for proof a non-inclusion proof. Like okay. Okay, then let's go back. So there's a UTXO pool with a append-only Merkle tree and nullifier pool with a mapping or sparse Merkle tree. And then let's try to write a circuit with these informations. Then what should be the public signals? The public signals should be the nullifiers. I mean the spent coin. Nullifier here, you can just think like nullifier is a hidden value of the spent coin. So you are revealing nullifier instead of revealing the detail of this spent coin. So public signals here can be nullifiers, and the root of the UTXO pool, and new UTXO you have generated using the transaction here. And the private signals should be the details of the UTXO. I mean, the details of the UTXO includes all the new UTXOs and spending UTXOs too. And also the Merkle proof of the spending notes, and also the ownership proof. And then we just write some conditions here. So nullifier should be derived from the commitment, which means like, I mean, nullifiers are from the spent coins, and the ownership proof should be valid, and the Merkle proof should be valid, and the spent amount and the new UTXO should have a same amount of the total amount of the sum. Okay, and Then here is another question. Like, this is just a example of implementation of the private transaction protocol using ZK-snarks scheme. And the question here is like, then how the recipient can get the new coin. So let's think about, we hide every value, which means that we also hide the owner. Then how the recipient can get the new coin? When we receive some fund using Ethereum mainnet, then you can just check from the Etherscan, and then there are some public values, so you can just know that, oh, I received some ETH. But in the private transaction protocol, there's no way that you can know the details. So there are two types of way. The first one is interactive way, and the second one is non-interactive way. So the first one, the interactive way, is like giving you some information. I mean, the sender gives information to the recipient. And then if the recipient accepts that transaction, then it goes to the block. So we can use the MPC or Schnorr signature here. And advantage is like we can guarantee that the recipient receives the fund well. But the disadvantage here is like the recipient should be online every time to receive coin, because it's an interactive way. So the example of the interactive protocol is Mimblewimble. Actually, I started the private protocol with Mimblewimble at first, and then switch it to a non-interactive way, which is Zkopru for now. It's Zkopru now. So the non-interactive way is like the Zcash is using the non-interactive way. It is using the memo field, so encrypting the transaction data using the Diffie-Hellman key exchange protocol. And the advantage is like the recipient doesn't need to be online. But there is a kind of a pretty a big problem here. Is like every user should try the decryption for every transaction to discover my UTXO. I mean, every UTXO has memo field, and every user should try decryption for every transaction's memo field using the own ECDH shared key. So for example, we have 1,000 transactions, and also we have 1,000 users. Then actually in the world, the decryption happened like 1 million times. It's kind of a little bit of waste of the computation, because that is only for like to discover my UTXO for user. So actually this protocol also has some disadvantage stuff, but pretty good for the user experience, definitely. So this is the reason why we are using the non-interactive way. Yep. Okay, then we have to think about the compliance too. I mean, recently this is pretty, yeah, everyone knows that something's happening. Like there's also some dark side of the privacy protocol, terrorism or money laundering or tax evasion, etc. So actually it is pretty important to keep keep it. Maybe some people are wanting the 100% of freedom, like 100% of censorship resistant stuff or something else. But actually, this is kind of implementing a tool that some party can censor some transaction without actually there's a tool to censor some transactions. I mean, this is a layer 2 protocol, and layer 2 protocol, layer 2 means that the coordinator, the block proposer, has a huge power to censor the transactions. So we are using that in that point here. So what we are using here is also the Zk-snarks, the subclip protocol, like having a spending key and viewing key together. So if you have a viewing key, to spend your UTXOs, user should have the spending key to spend the UTXO. But the details and the memo field is encrypted by the viewing key. So if anyone has your viewing key, then they can decrypt the transactions for you. So I guess that some government can run this kind of own layer 2 private transaction protocol for their own domestic payment system. In that case, government can reject some transactions from users who didn't submit the viewing key. And if they submitted the viewing key, then the government can track the transactions and also tax them, or they can just prevent some money laundering or tax evasion, etc. So this is a use case for the spending key and viewing key system. And I think that running a layer 2 protocol, layer 2 network on top of Ethereum is a pretty good choice for some like other governments, like other nations, because it gives a lot of connectivity to the worldwide finance system, which is Ethereum. And also along with that, they can protect the privacy and also have the auditable feature there. Yep. Okay, so to implement this protocol, we have some pretty complex logic here. So we have some spending key and drive the viewing key from the spending key. And viewing key becomes a nullifier seed and also becomes a public viewing key for ECDH, and also generate a firmware key and create some shared key, then create public spending key. So using all the stuff, we can make UTXO and nullifier. And also we make some Zkopru address with using the spending key and viewing key. So it's a pretty complex, but if you're interested in how it really works inside, then I think you can just take a look at the documentation for about the account model. And also I think I need to explain a little bit about the memo field here. So why I am explaining memo field here is because this is a layer 2 protocol, which means the call data is the most expensive here. So compressing call data is pretty important. But a UTXO has a kind of a 256 bytes of data. maybe it is like 280 or so. But if we use the one-on-one encryption and decryption, then the encrypted ciphertext is also costs 280 bytes of call data. So what we do here is compressing some data, like we have a token ID instead of putting all the 20 bytes of token address. So it means like we have only a limited number of tokens. So we register tokens on the smart contract, and then the token ID is just a modular 20 of the modular of the say token address, modular 20. So maybe DAI or USDC can have a same token ID. Like, so for example, if the token ID is like 7, then we just look up the token addresses, which modular is 7. And then, for example, then we have like, okay, we have some 30 candidates. Then we are just trying every token addresses to decrypt this memo with the 30 candidates. So with this logic, we can just reduce the call data a little bit. And yeah. Yeah, this is how we are just compressing the memo field data. And yeah, then let's talk about the deposit stuff. The deposit is the first step that users use Zkopru network. So to use Zkopru, you need to deposit a note. And at first, it should be the public information, because you need to put some ETH or put some token to the smart contract, and that is definitely cannot be private. Then the coordinator, actually the product accumulates these new deposits into a mass deposit object. So we accumulate the deposits and put them to the layer 2 block at once. Later. So once a mass deposit object is committed, then the coordinator can include that committed mass deposit into the new layer 2 block. And the next step is about the withdrawal. So users can submit a withdrawal transaction to the Zkopru network to exit. And a withdrawal transaction spans a UTXO and creates a withdrawal node instead. Because spending UTXO on the layer 2 and creates a withdrawal node, which can be used on layer 1. And these withdrawal nodes will be finalized, will be recorded in the layer 1 smart contract as a form of a local tree, and then finalized after the 7 days of finalization. So here, actually, recently, we got a pretty fun idea for about the optimistic rollup and the ZK rollup for about the finality. For example, for ZK EVM, like so, to verify a block, it takes like 30 minutes with a multiple AWS machines. So it means like if we implement a general state ZK rollup, then the minimum block period is like 30 minutes, which is not good for the user experience, definitely. So there is a very recent ideas like having a hybrid approach here. Optimistic rollup and the ZK rollup together. So we just submit the blocks every 10 seconds and generate the ZK proof in parallel. So people can use that just in an optimistic way without finalization. But after 30 minutes, they will be finalized with the Zkopru. And also, it is good. It is pretty good in terms of the security point of view. I mean, Zkopru is also actually is pretty new and relatively not verified that much. I mean, we really don't know where is some unknown vulnerability in the protocol. So if we have the fraud proof and the ZK proof together, then we can protect the vulnerability using the optimistic fraud proof together. So recently, this hybrid approach has came out, and we think that it'll be, yeah, it might be pretty fun to implement those. Like also for this private tranche protocol or some general state ZK rollup or etc. And there's also instant withdrawal feature that you guys might be already experienced in Optimism's bridge. So there is a 7 days finalization, but you can just withdraw instantly using Hop exchange or etc. This is like a prepay system. So, yeah. Okay, and the other one that I want to introduce here is a subtree insertion, but I would say Colk, I mean CAULK, Colk is better than this solution, I guess, but this also pretty makes sense. I mean, let's assume that when you have a 32 depth Merkle tree, how many hash computations you have to do to add 100 leaves to the Merkle tree? It's like 3,200 hash computation. So actually, a verifying like 32 computations, like 3,200 computations is not a easy stuff in ZK-snark or also on smart contract for the gas cost. So if we have a way that we can reduce computation, then it'll be pretty good. So what we thought is like having a subtree insertion. It's like this is actually a 32 depth Merkle tree, but we divide them into a 27 depth Merkle tree and the subtree of 5 depth. And making this Merkle tree and then adding these leaves to the main Merkle tree. In this case, to construct a 5 depth Merkle tree, like you need to compute to construct a 5 depth Merkle tree. It has 32 leaves inside it, and to compute the root of this tree, you need to compute like about 32 times, and then we can almost cover the 100 leaves with only 3 subtrees, which means you need to compute only like 100 hash computations, not the 3,200 computation. So it's like we can reduce the cache computations by 32 times compared to the with a simple Merkle tree insertion approach. So yeah, which means that this is 32 times efficient compared to inserting every leaf I buy it like to add some leaf. Yeah. I mean, this subtree insertion is like 32 times efficient. And the one thing that we are thinking about the optimistic rollup very much, while we also have the ZK rollup, is because we can describe more complex protocol using optimistic rollup, because we can define the every challenge cases using when we implement the more optimistic rollup. So in Zkopru cases, we have a lot of challenge cases, like for deposit, the deposit case is not committed, and for the header has some invalid deposit route, header has an invalid transaction route, or parent block is a /it block, and like this. So we have a bunch of some challenge cases, and doesn't it just look like kind of a yellow paper of Ethereum? So we can write everything as a smart contract code. So this is pretty powerful. So I hope that, I also think that ZK rollup, we should do the ZK rollup, and also we need to improve ZK rollup. But I don't think that we won't use optimistic rollup in the future. Optimistic rollup approach also has a good advantages, like I mentioned the hybrid approach, and also we can write a really complex protocol using this optimistic approach. Okay, I want to show our challenge cases a little bit here. So we have a contract in the repository, and you can see some challenge cases here. Like, so if you want to know about how you can write some optimistic rollup protocol, then I think you can see those cases. Like, we have a header validator, then we validate deposit route and validate transaction route and validate migration route, and etc. And these functions should not be called. I mean, if anyone is like called, then it means like slash. So you can check how we validate the block in the repository in more detail. And also we have a documentation about how the transaction looks like and how the block structure looks like, a very detailed at the documentation page. So I think you can see more details there. Okay, and there are only 3 more stuff that I want to share today. The next is private atomic swap. Private atomic swap is pretty important to implement third-party applications on top of private transaction protocol. So using the private atomic swap, we can implement merchant service. So when you buy something in the restaurant, then you give your token or your ETH, and you just get some NFT or something else. So this is kind of how to buy some digital assets in a private way. So this is pretty important. And also another example application is a private exchange. So let's assume that you want to exchange your 100 ETH or 101 ETH. with others, and you don't want to reveal the price. I mean, let's assume this is an OTC. Like you can do OTC in a private way if you use private atomic swap. And we are also having some fun experiments using the socialist millionaire protocol, which is for a matching the orders in a private way. And then we use private atomic swap. Then you can do the OTC in a pretty private manner. Okay, and the next one is about the privacy tax scenario, which means a centralized coordinator can generate a fake volume of transactions. So this scenario is like, I am running my Zkopru network. It's an L2, and I am the coordinator. And my friend just came here to use Zkopru network, but actually every transactions were fake transactions made from me. So if we make some transaction, actually I can just track the transaction graph a little bit. So this is pretty bad for the anonymity and privacy stuff. So we added a burn auction for the coordinator selection, which means to be a coordinator, you need to burn some ETH to be the coordinator, and we auction that. So for example, my friend Alice is a coordinator, and for the next round, she burned like 10 ETH. Then if I want to be a coordinator, I should burn like 11 ETH. And later, actually, Alice will get refund of burn ETH. Not burned, but staked. But I should burn like 11 ETH more than Alice to be the coordinator. The reason is because it's like the powers of Tao trusted setup ceremony. In the powers of Tao trusted setup ceremony, if you participated in the ceremony, then actually yourself is pretty safe, because if you didn't reveal your toxic waste to others, the powers of Tao ceremony is only dangerous when every participant revealed their toxic waste. So if any one of the participants destroy the toxic waste in a appropriate manner, then the protocol is pretty safe. Burn auction is a pretty similar concept. So if you be the coordinator, then you can add some your own anonymity sets into the pool. Then it lets others very hard to track the transaction graph. So this is pretty important for the anonymity. So we added this burn auction protocol for the coordinator selection. Okay, so yeah, this is all from today's presentation. This is TLDR, like it's a private transaction and instant withdrawal, private atomic swap, and my viewing expanding key, and the gas cost is pretty cheap, like 8.5 thousand gas per transaction for now. But it can reduce if we implement the proof aggregation and a little bit more optimization, then we can drop that maximum like 5,000 gas. So yeah, this is it from me. So thank you for listening my presentation today.
All right, thanks, Wanseob. Just a quick check. How much time do you have?
Yeah, I have plenty of time. It's okay.
Okay, because there's a long list of questions, and I'm not sure if we can get through all of them.
Okay.
But since you have time, before we jump into questions from others, I always like to ask our guest speaker just to give a quick introduction for you personally. Like, how was your introduction to Ethereum and how did you join Ethereum Foundation? Like, what was your story?
Yeah, so my story. Like, yeah, I started the private protocol. Like, I really don't remember the exact year, but had a talk at the DevCon Osaka and met Barry there. And Barry has some idea to improve the protocol. So we started to work together, and there was when I joined the Ethereum Foundation. Yeah.
Ooh. But like, can you share how you joined Ethereum as a space, like even before that? Like,
Okay. It's like, I guess it was like 5 or 6 years ago. I actually I did a startup before, like 2013, and made a startup with my friends and sold it to another company like 2014. And from there, I learned a lot of the modern capitalism there, how the startup works and how the corporation works and how the VC works. And to be honest, I thought that there is a pretty unfair game. So I just started to fall in love with the open source like Linux, because it was pretty shocking to me that there is no incentive to contribute to the code. And you know that code is one of the most valuable means of production. So isn't that sound like very communism stuff? Like they're giving up their incentive for the means of production, right? So it was pretty shocking to me, and I was I started to think about the culture and open source stuff a lot, and around that time I discovered Ethereum. So you know that we in Ethereum we just share everything. So it was a pretty shocking culture to me, and I was also naturally fall in love with Ethereum. Yeah.
nice. That's a really good story.
Yeah.
Didn't expect that.
Yeah.
Cool. Okay, so on to
That's a long
the
story.
yeah. One day when you come to KL, we'll hear more about it. Hopefully,
I'm sorry.
one day when you're here in Kuala Lumpur, we can
Ah,
hear more about your story.
yeah, I hope so.
Okay, but so questions from the audience. I think Chironjit asked like to clarify, Ethereum does not use UTXO.
Yeah.
So why did Zkopru use UTXO? I think you mentioned a little bit about how you don't see
Right.
how privacy can be done.
Yeah, right. Zkopru is not a standard protocol. We just did an experiment with optimistic approach and also with ZK-snarks. And what we want is shipping this protocol and build your own tool using these experiments. And yeah, I just wanted to clarify a little bit for about our approach here and why we have to use UTXO model is because to hide the transaction graph. Yeah. So UTXO model is the simplest way to implement the hiding transaction graph. Like, I mean, this is the diagram of how Zkopru transaction works. So for payment, there should be some inflow and outflow. And what we want to do here is like some of the inflow equals to some of the outflow. But we don't want to reveal which coins is used for those inflow. And yeah, so to implement this model, actually account model is too much. We don't need to use account model for that.
And what are some trade-offs with you deciding to do UTXO?
What are trade-offs?
Yeah, I imagine, you can correct me if I'm wrong, I imagine it's probably not generalized as a rollup
Yeah,
for you
right.
to do all kinds.
Yeah, that's
Are
true.
there any other trade-offs that you decided?
So if you don't use UTXO model, then it is pretty difficult to make it private. Yeah.
Okay, cool. Then okay, actually, Chichon just asked whether the optimistic approach was something you always had in your initial design. Yeah. Whether optimistic versus ZK versus any other approach out there, maybe not even doing a rollup at all. Was it always your original design to do an optimistic rollup?
At first, for Zkopru?
Yeah.
Yeah, it was like, to be honest, at the time we didn't have a good proof aggregation tool, which means it is pretty difficult to make ZK rollup. I mean, this is already using a ZK-snark, and we need to verify the ZK-snark proof is valid or not. So rolling up this ZK transaction using optimistic rollup is Zkopru, and rolling up the ZK transaction using ZK rollup is ZK rollup. And at the time, we didn't have a proper tool for the proof aggregation, so optimistic rollup was the only possible choice at the time.
So are you saying today you could do a ZK rollup?
Yeah, and we can do that in ZK rollup definitely, but I think hybrid approach is better. Yeah.
Okay, cool. Then Justin asked whether Zkopru differs from Bitcoin Lightning in terms of the ZK-snark implementation at the prover output side.
Actually, I'm not familiar with the Lightning implementation, so I don't think that I can give a good answer here. Yeah.
Then maybe one related question would be like, as far as you know, are there like certain groups of categories of approaches towards privacy? So like one simple kind of type could be like to have mixers versus rollups versus your own native blockchains, and to have it interactive versus non-interactive. But like, is there like a map of different approaches towards privacy on blockchains?
Briefly, so we can use privacy for finance, but we can use privacy for social identity too. So recently we are more focusing on the social identity, which means like allowing you to vote privately and anonymously. So there are some two big use cases for the privacy. So the first one is the finance, and the other one is a social identity stuff. And technically, the most important is the membership proof, and we don't have enough implementation using Colk now because it's really new stuff. So I guess in few months we may have a multiple implementations of the membership proof using Colk, but the proof size might be pretty big, so it will be pretty fun to see how we can compress that using ZK rollup there.
Okay. So a lot more room for exploration for the
Right.
PSE. So when you mentioned hybrid approach, right? So theoretically, can hybrid approach also be used by the current optimistic rollups and the current ZK rollups?
Yeah,
So
definitely. I
it
definitely think like that.
so it doesn't have anything to do with privacy in that sense. Like you could use it
Right.
just for scaling.
Yeah, right.
Nice. Yeah, that's a whole new rabbit hole. But Chichon asked, what is the decentralization strategy of Zkopru, and how are you gonna start things off when you have mainnet?
Yeah, so decentralized plan. The borrowing auction is the decentralization strategy for us. So we don't think that there should be multiple coordinator. Single coordinator also can work well, but there should be a way to be a coordinator when you want to be. So this is the way we implemented the decentralization for the coordinator selection. And for the mainnet delivery, we don't have a plan to deliver this mainnet. It's a research experiment, but we are pretty sure that everyone can use this for their own product. Like, so personally, I really encourage other governments to adopt this system. Then maybe I think I can just give some support for implement the system for their government, or maybe or their CBDC or etc. Yeah, so we don't have any plan to deliver this to mainnet.
That's really cool. So CBDCs that are naturally private, I think would change the conversation towards CBDC that a lot of people are having. So yeah, thanks for your public service. But so one question on the burn auction, right? So does it mean that the auction continually goes higher and higher, like permanently or indefinitely? So like it goes from 10 to 11 to 1,000 to 10,000.
The auction rounds just renews every round. I mean, yeah.
Okay. And at the end of the round, only the last person who wins it actually spends or burns their ether.
Right.
Nice. So when we talk about Zkopru rollup, what are the sort of roles that are involved? Like other rollups, we have sequences, potentially even data availability committees.
Yeah.
So is it just the coordinator, or there are other roles as well?
Coordinator is a sequencer here, and what coordinator here is like generating block and also verifying the snark is what the coordinator does here, and just ordering the transactions.
Is there any data availability kind of mechanism or kind of role?
There is an idea to implement the instant finality. Is like a coordinator gives you a signature that the transaction will be included in the next block at the specific index. So if your transaction is not included in that index in the next block, then the coordinator will get slashed.
Okay.
So we haven't implemented this, but
is there an actual, I think I read in your Medium post announcement that there is about to have been a testnet, so there should be one by now.
Yeah, we have a testnet now.
Okay.
Yeah.
How do people like get in, like deposit or?
You can go to Zkopru network, then you can use an application there, test application there, and it's on Goli and Optimism testnet too.
Optimism Gorley, I guess.
Yes, yeah, Optimism Golly, but maybe it'll be terminated in few weeks, I guess. So we need to
Oh no,
migrate.
it's on Optimism Coven then, because Coven's the ones that are about to be
Okay.
deprecated.
Okay, yeah.
But basically, if as long as you have, let's say, Gorley ETH, then you can just deposit to this bridge contract and then use the
Yeah, right.
Zkopru network. Nice.
Right.
We should probably do this at the next meetup.
Yeah.
Yes, it's kind of hard to find testnet Ether, unfortunately. And then related to this is so to the sequencer, right? So you mentioned just now that a sequencer could potentially censor a transaction.
Right.
So how would they know? Because it's a private rollup, right? So you don't know
Right.
which wallet belongs to which person. So let's just say there was some terrorist that was found. Like, how would, let's say, the coordinator in this case know that this transaction is being done by the terrorist instead of by someone else?
So for that, we have viewing key. So coordinator can reject transactions from an account who didn't submit the viewing key to the coordinator. Does it make sense?
So what would be the role of the viewing key here? Like, can the terrorists just provide the viewing key to the coordinator?
Viewing key lets you see the details of the transaction.
Okay.
Yeah.
So when you say details, you mean like the amount and the from and the to addresses?
Right.
Okay. So then it's not 100% private. Like at least for a particular transaction, you are exposing your details to one party who is the coordinator.
You don't need to give your viewing key for every time. So if you don't give your viewing key, then it's 100% private. But if you gave your viewing key to someone, then actually that is not private, at least for that for them. So
okay.
So we have a kind of two approaches to achieve the compliance. The first one is having a global viewing key stuff, which means government has only one viewing key, and then we add some encrypted information to the memo field together. But this is pretty we need to use more call data to support this kind of global viewing key. And also, if the global viewing key is leaked, then every transaction just becomes transparent. So yeah.
Okay. So is it allowed for a user to make a transaction without exposing a viewing key? Like, can the coordinator allow that to happen?
Yeah, it depends on the coordinator implementation.
Okay.
So yeah.
So it's like theoretically, if I wanted to keep my transaction completely private, I could bid for the auction for that particular transaction.
Right. Then you can 100% guarantee the privacy.
Well, so related to that, Kevin just asked, what would prevent a bad actor from taking up the coordinator role, aside from having to spend a large amount?
Bad actors from taking up the coordinator role. We don't have that tool here. So to prevent that bad actor, you need to spend more.
I mean, they would have to keep on burning their ETH if they want to keep being the coordinator forever, right?
So yeah, let me clarify a little bit. Here we implemented the protocol, and the coordinator selection logic is very modular. So burn auction is one of the coordinate selection logic for the decentralized version. But if a government or if a city wants to implement their own coordinator, they don't need to use this burn auction stuff.
And would there be, naturally there will be transaction fees, right? So
Yeah, right.
the coordinator would also earn from that transaction fees.
Right.
Okay. Anyway, so moving on a little bit. Chichuan asked earlier, I'm not sure who asked, but in case of a transaction fraud or smart contract bug, how would Zkopru address this issue, considering the implementation of encryption of transaction or data privacy after finality of the UTXO Zkopru channel?
Okay.
I'm gonna send this here just in case, so you can read inside the chat.
Yeah, I'm reading it in from the chat. So smart contract bug, transaction fraud after the finalization. We thought that there might be a migration tool at first, and also there's a migration feature too. But once this kind of a transaction fraud or a smart contract bug is happened in the protocol, then actually it is like 100% ruined. So it is pretty important to have a very kind of 99.99999% perfect contract audit. So we had a lot of some internal audits and also external audit too. But actually that doesn't guarantee this protocol is 100% safe. So that depends on the trust. Like, we can consider that you can consider this protocol is safe or not. Yep.
So it might be cool for, like, let's say small communities to try it out, and then accept that their funds might be completely burned, and then share some feedback to
and all, that also be some approach, but I would like to say that if anyone is interested in this kind of a very destructive situation, then it will be a pretty good research topic and experiment topic.
Yeah.
Because we don't have that kind
Then there's a question from Chichuan. Is Zkopru written using Circom, and what underlying proof system are you using?
Right. Zircon and GROT16.
Okay.
Yeah.
And well, I think you've kind of answered this question already. Has Zkopru undergone a trusted setup?
Yeah, we did. Yes.
Okay. And how much TPS? I think you mentioned it was, sorry, how much TPS do you expect Zkopru to serve?
The maximum TPS is like 100 transactions per second right now. Yeah, the maximum transactions per second is 100, about 100. Yeah.
Okay. And so going back to the atomic transactions, I believe it's not fully generalized or composable on Zkopru. So what kinds of smart contract type transactions can be done on a Zkopru network?
Yeah, so honestly, we have only 2 example applications to use private atomic swap. Is the merchant and merchant service and the private exchange. Yeah.
So would it be possible for let's say any future implementer to build other applications on top, or is it like very restricted? Okay.
I think it is pretty restricted. Like it is pretty restricted to build something on Bitcoin network, isn't it?
Mhm,
So
mhm.
yeah, it's pretty similar. We can
Okay.
build something, some script using the memo field, and also we can add more logics using the optimistic rollups challenge
Mhm.
logics. But actually, this is a UTXO model, so it is pretty restricted. Yeah.
All right. All right. So like I'm trying to imagine like a CBDC that's trying to do like cool, interesting things like I know auto charging taxes or doing some smart stuff with the digital currency. But
Yeah.
then probably not in this case. Like maybe they would have to apply some other um, layer or some other rollup to do that.
Auto charging is also pretty possible in using current Zkopru network too, because the coordinator can only accept the transaction with the UTXO that includes the UTXO for the coordinator.
All right. Okay. Then I think I'm gonna try and finish this before 9:30. So if anyone has any last questions, feel free to shoot them in. Or if I missed any, please feel free to paste it again in the chat. So one question I have is so there is this EIP 4844 to do blobs inside the mainnet transactions. And that's generally to like make it cheaper for optimistic rollups. I believe make it cheaper to have call data inside. Someone can correct me if I'm wrong. Does that apply to Zkopru as well? Like, does it matter to you?
Yeah, so because it's layer 10 affects a lot from cold data cost. So yeah, definitely yes.
Okay. And if you imagine there's like 100 governments or cities or different people who are running their own implementations of Zkopru, then that would also be essentially competing with each other, right? For the layer one gas cost.
Getting yeah, that could, yeah, it might
Okay.
be.
Okay. Yeah, but then we'll look at other sort of scaling answers. I guess if you reach 100 governments using Zkopru, that's very
Yeah.
ambitious already.
Yeah, right.
um, yeah. Okay. So Chichuan asked if how can someone, let's say in the ETL community, contribute to Zkopru or any other PSE projects?
Yeah, good question. You can explore the repositories, PSC repositories. Actually, our previous org is like, oh, we can use this anymore. Privacy scaling explorations, and we have some bunch of some projects here. But actually, there are also some other project that's not here, like Zkopru or etc. So you can explore some issues over there. Yeah. And also we are we are preparing a use web3.xyz stuff. I mean, actually, this is from our another EF member that let you explore some good first issues here. So you can also find some privacy and scaling explorations issues using this tool. Yep. Okay. Thank you for your good question.
Nice. And so not to forget, Joe asked, how would NFT transfers work when it comes to Zkopru?
Yeah. Yeah, our another wanted list is like having ERC 1155 too, but we are supporting only the ERC 721. And how it works is like where is it? Yeah, I think we can go to the. You can take a look at the UTXO model here. And we also have some NFT field here. So it's like just transferring one NFT or transfer some ERC20 or it only. So that we have some three options. If you want, you can transfer ERC20 or you can transfer it or you can transfer NFT. Yeah.
Nice. All right. So I think probably the last question before we let you go. We've heard a lot about Zkopru, but your role at the PSE, as far as I understand it, isn't limited to just Zkopru. So in like a couple minutes, do you mind sharing other cool, interesting projects that the PSE is working on that people here might be interested to find out more about?
Okay, so I am also coordinating projects inside the team. So I guess it is a good chance to share what we are doing. Just move on, please. Okay. Yeah, you can just go to the applyzkp.org. Then we have a projects list here. So Interact, TLS, Notary, Coco, Xylophone, ZK-chat, ZK-kit. But let me introduce some fun stuff here. So the rate limiting nullifier is a protocol using a Schumer signature that reveals your private key if you send too many messages at a given time. Yeah, so it can be used as a spam protection protocol. So we are trying to apply this to multiple some use cases. And Unirap and Unirap Social is a reputation implementation using a on the anonymous identity. So, for example, you can prove that you have a certain amount of reputation without revealing your real identity. And these kind of things can be used for the new types of social media, which can be pretty censorship resistant, but also might be resistant to some bad contents. Yeah. So we are trying these experiments too. And BLS Wallet is a scaling tool using BLS signature. So yeah, you can use that already. And also Semaphore is we are making Semaphore as a standard protocol for the membership proof, I mean ZK identity. So you can visit Semaphore, then you can see some quick setups and boilerplates and the documentation about how it works. And ZK Keeper is one of the projects we think very important. That is, recently we are having more and more ZK related applications, but because of these characteristics of ZKP, it is pretty difficult to find if there is any kind of a hack or leak of information or etc. So for example, you generated some witness using your browser, but the browser application was leaking your information. But then actually that is pretty difficult to figure out which account is leaked, because everything is private or everything is like hidden. So someone can generate some fake proof continuously using the leaked information. So it is pretty important to have a secure environment for the ZK-snark proof generation environment. So this is a project for that. And ZK EVM is a ZK rollup implementation of the every VM, of course. So this is a key of the ZK rollup. And Macy, we are using Macy for the quadratic voting and anti-bribe system. So this is also, we are trying to apply this Macy to some other use cases as much as possible. Yeah, and actually TLS notary is also pretty cool that this is a I mean, this is a little bit stealth, so I think that I'm not sure that it's the right time to share this, but yeah, this is based on RSA, but yeah, I hope that we can have another time to share about the sales and trade later. Yeah.
That would be amazing. And like Kichon said, we will try and get other people and other PSE projects to share as well. If it's anything as exciting as the one today, I think we'll have a lot of content to go over.
Yeah.
So thanks everyone for joining. I think today there were some very, very good questions. And most of all, thanks Wanseob for your time. We've gone more than an hour and a half. So yeah, thanks a lot for sharing your time with us. And let us know whenever you're in KL at all. We'd love to host you and we'll show you around Malaysia.
And Interscan office.
Thank you so much.
All right. Yeah. All right. So thanks everyone. We'll be sharing the recording for this later. And see you guys.
Oh yeah.
Bye-bye.
Bye-bye. Thanks, Wanseob. Just a quick note. We are going to have like a Starknet Malaysia community meetup at the end of this month. So for those who are interested in knowing more of the recent projects that we built for IFSO and also for the recent Starknet House Hackathon, we will be sharing those as well. So it's a good time for you to get your hands feet wet into the development of the Stark community in the Starknet ecosystem. It's going to be like from the A to Z. We are going to show like the front end to the integration and to the how Cairo is being written and the testing. So yeah, we have 2 projects to showcase. So that's pretty cool. Thanks to the IFSO for giving us the opportunity, and thanks Starknet House also for giving us the opportunity to hack and build fantastic projects. So yeah, look forward to seeing you guys.
All right, thanks, Yichuan. And we will most probably have the next in-person meetup on the 8th of September. Not confirmed yet, but most likely. 7th of September. So we'll let you guys know more details later. And if you're in the meetup group, you will get the notification when it is created. So again, thanks a lot, everyone. And thanks a lot, Wanseob, for sharing your time with us.
Thank you.
Bye-bye. Thank you.
Bye-bye.